Okay, I have a function f of x equal minus 1 over x, and I've got a graph of it here. I'm also looking at the point 1, negative 1. In other words, if I evaluate this function at 1, I'm going to get negative 1 back, so point on the graph right there, I'll kind of highlight a little bit. See it on the graph, 1, negative 1. And I want the equation of the tangent line at this point. I want the equation of the tangent line. Now, to get the equation of any line, I need a point and the slope. I've already got a point because the 1, negative 1 is the point of tangency, so that'll be on the line. I just need the slope. And to get the slope, I'm going to find the derivative function. And the derivative function is the limit. This is the definition that I'm going to use of the difference between the function evaluated at x plus h and the function itself over h as h goes to 0. So I'm going to apply that to my function. Got the limit as h approaches 0. My function evaluated at x plus h will be negative 1 over x plus h, and then subtract my function all over h, and this will give me a negative 1 over x plus h plus 1 over x all over h. And the limit as h approaches 0. Now, this is a complex fraction, so one way to reduce it is to multiply numerator and denominator by the least common denominator of the inner fractions. And be careful though, I'm going to go ahead and multiply numerator and denominator by this, but notice I have two terms in the numerator, so I've got to distribute that into both of those, and then that will give me the x plus h's cancel, so I have a minus x, and then multiplying by the second term the x's cancel and I'll have x plus h, and then in the denominator I'll have an h times x times x plus h. And then I get the limit as h approaches 0 of, well, I'll have a minus x plus x, which will cancel. And then I'm just left with h in the numerator over h times x plus h. And my h's cancel. So I'm left with the limit of, or the limit as h approaches 0 of 1 over x squared plus x h. And as h goes to 0, this is equal to 1 over x squared, because the xh term in the denominator will then vanish. So I've got f prime of x equal to 1 over x squared, and I want to find the slope of the tangent line at my point of tangency, so I'm going to evaluate it at the x coordinate, and 1 over 1 squared is 1. So now I have a point and I have the slope, and I'm going to go ahead and plug that into my slope, or my point slope form to develop my equation. y minus the y coordinate, which is -1. My slope is 1. And x minus my x coordinate. So I have y plus 1 is equal to x minus 1. And subtracting 2 from both sides, I have y is equal to x minus 2. So that's my equation. And I've got my line drawn there. And you can see that the slope is 1 and it hits the y-axis at -2. So the equation again of my tangent line is y equals x minus 2.